Day 288 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 288 and we're still going strong, y'all. Today we have question number 64, minimum path sum. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now let's see what the question says. Question says, given an n by n grid filled with non-negative numbers, find a path from top left to bottom right which minimizes the sum of all numbers along its path. Note, you can only move either down or right at any point in time. All right, y'all. So now that we know what the question is asking, let's go ahead and take a look at these examples so we can know exactly what it is that they want us to do, right? So in example 1, we have the input is a grid. It's an n by n grid. First row being 1, 3, 1. Second row being 1, 5, 1. Last row, third row being 4, 2, 1. So once again, as you can see, each one of these arrays inside of the bigger arrays, a 2D array, each one of these smaller arrays represents a row. This represents row 1, boom. This right here represents row 2, boom. And this right here represents row 3, boom. In this case, the output is 7. Explanation says because the path 1, 3, 1, 1, 1 minimizes the sum. So remember, we want to get from right here, the top left, which is right here, to the bottom right, right? It says from top left to bottom right. We want to get from right here to right here with the minimum sum, with the smallest sum that we can create. And in this scenario, this is the path we would take. We go 1, and we can only move down or right. We can't go up or down. Up or left. So as you can see, we just go to the right, then we go down, down, boom, just like that. And that gives us 1 plus 3 equals 4 plus 1 equals 5 plus 1 equals 6 plus 1 equals 7. That's why the output is 7. Let me just give you an example of where of a different path so you can see that path would be higher than 7, right? So say we went down, that'd be 1. Say we went down again, down, that'd be 2. Went down again, now we're at 6. Then we go to the right 1. Now we're already at 8. You know what I'm saying? The final path will be 9 if we go all the way to from top left to bottom right. This path right here will give us a value of 9. It's not what we want. We want the minimum path. In this case, it's 7. We already know it's 7 because they're telling us. But I just want to give y'all an example so you can see for yourself that you could try it out yourself. Take any other path you want, and I bet you it'll be more than 7. So now that we know example 1, let's go ahead and look at example 2, right? So in example 2, we have the input grid. It was an n by n grid with the first row being 1, 2, 3, second row being 4, 5, 6. The output is 12. So let's just go ahead and copy and paste this over here so we could visualize it better. So that'd be the first row. This would be the second row. Boom. As you can see, it's 12. They go from 1 to 2, that's 3. Then to 3, that's 6. Then down 1, that would be 12, right? It's the same. They did the same path that they did in example 1. We just went over this way and this way. And then we went over to the right, then we went down to the bottom right. And that's how we got our path to 12. As you can see, just again, so you can see, say we went 1, then we went 4, that give us 5. Then we went 5 to the right, that give us 10. Then we went right, that give us 16. Or if we went 1 to 2, that give us 3. Then we went down to 5, that give us 8. Then we went over, that give us 14. All of those are bigger than 12. Remember, we want the smallest path, and in this case, it goes 1, 2, 3, then down to 6, which will give us 12, and that's how we got 12. So just remember, we want the smallest path sum from getting from the top left to the bottom right, and we just want to figure out how we can do that. So, and then we want to return the sum of that path. We're not returning the actual path, we're returning the sum of the entire path. So that's important as well. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult, so let's get started. Now, the first thing we need to do is we need to create a mutable copy of the input grid, which will store the minimum path sums for us. So in order to do that, we could just declare a variable we call it matrix. Then we'll say colon, open up the two parentheses, create a 2D array of, not parentheses, square brackets, create a 2D array of integers, and we'll just set that equal, we'll initialize that with grid. Boom. Then we're gonna come right down here, and we need to get the number of rows. So in order to do that, we're gonna say let n equal grid dot count minus 1. That's going to give us the rows. Now we need to get the columns. To get the columns, we'll say let m equal grid square bracket 0 dot count minus 1, and that's going to get us the columns. Now we need to iterate through the grid row by row and column by column. So in order to do that, we're going to use a for loop. We'll say for I in 0 dot 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 n, then we're going to open up the brackets. Then we're going to say for j in 0, this time we say dot dot dot, but this time we're going to say m instead of n, then we're going to open up the brackets. Now we need to start with the current sales value. So in order to do that, we'll call it variable, declare a variable, we could call it step, and we'll set that equal to matrix square bracket I, come outside those square brackets and say square bracket j, just like that. Then we need to see if it's not in the first row or the first column, then we need to take the minimum path from above or from the left, because remember, we can only go down or right. So we have to take, in this case, we're either gonna, if we're right here, we can only check from the left, or we can check from above, right? So in order to do that, we are going to say if I is greater than 0 and two and signs, j is greater than 0, then what we're going to do is we are going to say step plus equals min square bracket matrix open, not square bracket, min parentheses matrix. Now we open up the square brackets and we're going to say I minus 1. Then we're going to come outside of those square brackets, we're going to put a square bracket j. Then we're going to say comma, and we're going to say matrix square bracket I, come outside that square bracket and say square bracket j minus 1, just like that. And this is going to return the minimum of this or this, whichever one is smaller, and then it's going to increment step. Boom. Then we could come right here and we could say else if, let me give y'all some space, make it easier to read. Then we could say else if I is greater than 0 and two ands j, and then we say two equal signs as well is equal to 0, open up the brackets. So if it's in the first column, that means we can only come from above. So in order to do that, we're just going to say, or that's what this is going to handle. Then we're going to say step plus equals, we're going to increment step by, then we're going to say matrix, open up the square brackets, I minus 1, come outside those square brackets, and we're just going to say square bracket j. Then we're going to say else if it's in the first row, then it can only come from the left. So we're going to say else if, else if j is greater than 0 and I equal 0. Boom. Then we open up the brackets and we're going to say step plus equals matrix. This time we're going to say square bracket I, come outside those square brackets, and we're going to say square brackets j minus 1, just like that. Now we need to store the computed minimum path at this cell, right? So we're going through the cells, and we need to keep track at every cell. So in order to do that, we're going to say matrix square bracket I, come outside that square bracket j equals step. Boom, just like that. And now, lastly, but certainly not least, we need to return the minimum path sum, which to reach the bottom right cell. So in order to do that, we could just say return matrix, square bracket n, come outside that square bracket m, just like that, y'all. And that should be all she wrote. Let's run it, see if we can get it first try. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it, because there's no guarantee, as I'm sure y'all are aware. And look at that, y'all. 2 milliseconds beats 31.90% of users with Swift, y'all. Don't worry about those time complexities right now, especially if you're just getting started on your LeetCode journey. Right now, we just want to be able to solve the problem that's presented to us, and we want to be able to learn from or understand the solution that we've used, right? And I feel like this is a good, easy to understand solution, and we'll be able to apply the knowledge that we've gained from this solution and future solutions when we start to work towards better run times. But once again, right now, we're just focused on being able to solve the problem that is presented to us and be able to understand the solution that we've used. So with that being said, y'all, make sure you get one more look at the code. One more look at the code, y'all. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. I'll see y'all then.